Quantas vezes por ano você visita um médico ou faz exames? Agora imagina que você pudesse monitorar a sua saúde por meio de sensores que são vestíveis, ingeríveis ou até implantáveis. Será que a gente pode confiar a nossa saúde a que se chama agora medicina exponencial? Esse é o tema do meu papo aqui com o Daniel Kraft, doutor da Singularity University. What's the meaning of Exponential Medicine?
Obrigado. Well, Exponential Medicine is a conference I started at Singularity University 8 years ago, where we look at the convergence of technologies. Some of them are exponential, some of them are just moving quickly, whether it's 3D printing or robotics or artificial intelligence or low-cost genomics or sensors or Internet of Things to synthetic biology to drones. How do we take these technologies and use them in new ways to address challenges in healthcare, ranging from helping us live longer, healthier lives, health span, to doing a better job of doing early diagnosis, anywhere, anytime, at lower cost. How do we make therapies less toxic and more effective, whether that's an app, a digiceutical, a medical device, software? And then also, how do we even think about discovery? How do we connect the world in new ways to do clinical trials and advance healthcare and democratize it around the planet? So Exponential Medicine is a conference. Exponentialmedicine.com has many of the talks and lessons, but where we bring together a community of 800 innovators from 42 countries last year to look at where we can reshape and reimagine healthcare with the lens of technology, but also understanding design thinking, systems, politics, because the future of medicine is not just about technology. It's about how do you bring new innovations to actually come into the clinic so that you as a patient or I as a doctor can actually use that in real life. Well, the question is, what are you trying to measure? I mean, right now we're in the age of wearables. I have a Fitbit that can track my simple steps and my sleep. If I see changes in my sleep or my heart rate on my Fitbit, that could be useful as a simple tool, as a change in your health that maybe you or your doctor should know about. And then, of course, now the Apple Watch is FDA approved, and I can do my EKG on the watch and determine do I have a funny heart rhythm, or it can even measure if I had a fall and call an ambulance. So in terms of trusting a kit, some of them are FDA grade, highly medicalized. Some could be a simple consumer device. The challenge is, how do you take information from that and make it useful? So I think we're in the evolution of having essentially a medical tricorder, a device at home that you can use to not just take your temperature and your blood pressure, but to integrate that data with machine learning and artificial intelligence, knowing what's normal for you and when things are changing, and using that as a tool for early triage to pick up disease at stage 0, not stage 3 or stage 4. So I don't think it's a question of trust right now, but how do you connect the dots between the data and make sure it can be used to guide whether you have an infection, signs of Zika virus, malaria, cancer, pneumonia. Is it a virus or is it bacteria? And that's going to get better and better very, very quickly. The challenge is, who regulates it, who pays for it? How does your doctor and healthcare system interact with that information? And how do we use that to improve outcomes and lower cost? Well, part of that shift is to move from what I like to call sick care to health care. Our sick care model is usually based on little bits of data, blood pressure, EKG, labs, only in the very small percentage of time that you go into the clinic or the hospital, or you end up in the emergency room. So then we end up with a reactive sick care system. I wait for the patient to show up with a heart attack or a stroke or advanced cancer. Part of this new evolution of continuous, proactive healthcare, using Internet of Things, 5G, sensors, wearables, omics, will be much more continuous to give you early warning, like the check engine light in your car.
Before you're having a heart attack.
Before you have a heart attack, stroke, or other problem. And how will your doctor play a role in helping guide you through when that check engine light goes on? Just like today, if you're driving and the light goes on, maybe you should go to the mechanic. Then the mechanic does the analysis of your engine and learns what to replace before your engine blows up. So that means the role of the doctor, the role of the patient, is not just to be waiting to have a problem and go to the doctor or the nurse, but to be a co-pilot of care, to be part of seeing their information, understanding what it means in their own context. It might be in Portuguese or English or Spanish, depending on your age If you're a baby boomer or a millennial, you might need a different interaction with that information. Some might want to do through virtual reality. Some might want to text their doctor. Some want to be there face to face. So it's not like a complete shift. We need to blend some of these new possibilities into the practice of medicine and also understand how we pay for it moving forward as well. Forever is a very long time. I think we want to not just optimize number of years, but we want health span. We want to be 110 years old, but able to walk, think, talk, contribute, get around, think. You don't want to be stuck in a nursing home and just live more years. Right now, there's been, I think, very few humans that live more than 120, 122 years. There may be a limit to our normal biology. But if we can learn to be very proactive, very early in life, good diet, exercise, social connection, a lot of the impacts for longer life are not high tech, but are some of the basics. Clean water, food, vaccination. But I think, no question, we will start to live longer and longer, and maybe we're starting to now hack our biology with gene editing, some drugs that might extend our lifespan and change our biologic clocks. We already have our medical devices that are devices that augment our brains. Actually, it's, how quickly technology is moving. This I have in my pocket is a 10-year-old Apple iPhone. 10 years ago.
This is one of the first, isn't it?
Yeah, second one. 10 years old. It was amazing 10 years ago. Oh, amazing. Wow, Apple II, iPhone 2. Now it feels slow and low resolution and clunky. Now my iPhone 10, okay, now it feels amazing. Comparison, right?
Well, of course.
But in 10 years, this will seem antique. Maybe it will shrink into my contact lens, or I'll have an implant in my ear, hearables, or will fit into your ring. We'll just think and communicate. So technology is advancing. The challenge for healthcare is how do we start to leverage these technologies? Even our smartphone today is becoming a medical device. This has a camera that can look at my eyes if they're turning yellow or signs of a stroke, or the camera can pick up my heart rate, maybe even soon my blood pressure. It can be used to attach a laboratory. So a nurse in a rural village in the Amazon can use this to be connected to an ultrasound device or a laboratory, or there's USB genomic tests, so you can start to do genetic testing anywhere, anytime for lower amounts. So particularly in large countries like Brazil, you have a very large population spread out. This can start to bring healthcare to interesting places that didn't have access before. Maybe you'll send in the drone. And then for specialties, whether you're a cardiologist or a plastic surgeon, you can take a picture on the phone now and show that patient what they're going to look like after their surgery. You can use that as a coach to help them stay on a healthy diet or to quit smoking. We're in this era of prescribing apps and not just drugs and devices. So it's a very interesting time. Now the opportunity is to connect the dots into our healthcare system so that it really becomes impactful. Yes, I mean, exponential is honestly a little overused of a word. Not every technology is doubling in speed and price. Things like genomics are getting exponentially cheaper to sequence. 5G, communications are getting exponentially cheaper. But things like 3D printing is moving, but it's now a 30-year-old technology, but it's starting to get better and better. Some technologies like artificial intelligence are now ramping up and getting exponential. Others are how you put them together, the app with artificial intelligence, with the big data. Can we build a Google Maps or Waze for healthcare by all sharing all the data in Sao Paulo with what happens in Rio? Just like you're driving in the traffic in Sao Paulo, not great traffic, I've been there. Wouldn't it be nice if we had a guidance for our health journey based on who we are, what kind of car we're driving, right? You might need a different set of preventions and diagnostics and therapy than I do based on your age and where you live and your genetics. So it's an interesting time to think about putting these things together so we're all more empowered to do smarter, better, cheaper healthcare, not just sick care. Sensors are getting cheaper and smaller to the point that some are being embedded into contact lenses to maybe track your blood sugar, or maybe even give you, vision around the world. Maybe you can see that donut, maybe you shouldn't eat that because your calorie count's up over the day, or it could start to be a sensor as well. So we're in this internet of medical things where these sensors can start to go everywhere, anytime, and can start to give us an understanding of what your normal digital exhaust looks like. Right? And when it starts to change, maybe we need to get you seen and a better, deeper evaluation. So it's not about any one technology, it's how we're putting them together and they're converging to let us address challenges of aging populations, access to care, how we take the data and make it useful, how do we help our regulators, whether it's the FDA or an insurance company, pay for some of these new incentives and move to an era of not just paying to treat disease, but paying to help prevent disease and drive better outcomes. Well, we're used to evolving very, very slowly. Darwinism, evolution can now be hacked. We're now in the era, pretty fast-moving era of gene therapy with technologies like CRISPR. And we saw earlier this year in 2019, the first examples, not done ethically, of maybe putting CRISPR to modify a baby in the embryo in China.
Yeah.
So hopefully the future will not be genetically modifying babies randomly, but maybe to prevent a genetic disorder like sickle cell or thalassemia or risks of certain forms of cancer. On the next side of the equation, what if we start to change genes that give you more height or blue eyes or more intelligence? Lots of ethical questions there. What happens if we have a population of genetic haves and genetic have-nots?
Yeah.
And what happens to our evolution when some groups can speed that up and control the engineering of our next generation? So many areas are set for change. Some of the ones that are going to get interestingly impacted by the era of artificial intelligence are starting to happen. Radiology, it's starting to be read by machine learning and AI better than a radiologist. Dermatology, looking at pictures of your skin and comparing it to thousands of images and data sets. Some of your audience are ophthalmologists. Robotics and AI are already playing a role in ophthalmology to do eye surgery. Corrective eye surgery is not done by hand. It's often the laser robot that's programmed with the help of the ophthalmologist or optometrist to do an eye surgery. So we're going to see certain fields change. Radiology, pathology, dermatology, which is a lot of looking at images and looking and trying to compare and make a diagnosis. That can be enhanced by, not replaced completely by artificial intelligence, but will come blended together. For some fields, again, like ophthalmology, we'll see more and more elements of imaging of the eye aided with artificial intelligence. Google DeepMind has already done some incredible work to look at the retina and be opble to predict diabetic retinopathy. It can tell you if it's a male or female, weight, risk of stroke, risk of heart attack, just for looking at the eyeball. So the ophthalmologist and the AI imaging of the eyeball may become a very important lens for early diagnosis and prediction. And now there's some new gene therapies, even CRISPR. The first gene editing studies are for a form of blindness that is a genetic form. So we're going to see some very interesting new potentially cures for some eye blindness-related genetic disorders. For the folks who are plastic surgeons, you can now use technologies like 3D printing to already being done to help augment certain surgeries. You might have lost an ear from an animal attack or bite. You can help maybe reconstruct that. It's already often done by hand with the cartilage from the ribs. Now we'll start to see biologic printing that's going to augment certain surgeries. We're now using augmented and virtual reality. You can take a picture of your patient and have them try on different noses or chins, or here's before and after based on their face, not just looking through a catalog. And that might help patients make better choices and have better outcomes. And then surgeries are going to start to become, whether it's ophthalmology, plastic surgery, general surgery, orthopedics, I think there'll be an era where you're going to start to be guided through your surgery. You can have an expert AI mentor who's looked at thousands of surgeries and is watching you go through step by step. Oh, watch out, don't cut that nerve. Or here's a very customized surgery that might need to be done. Or you will train for your surgeries in virtual reality before you ever go into the operating room, particularly for cases that are particularly complex. Or you might be in Sao Paulo and have a plastic surgeon here in San Francisco watching over your shoulder virtually and helping coach you through a procedure. So we'll start to collaborate in new ways and can do that virtually. So, and then when you send a patient home after an eye surgery or plastic surgery, their app can help track how they're doing, give them guidance, look at their wounds and their stitches. Do they have an infection or not? You don't need to bring them in. They just take a little peek. Oh, looks good. Send them back. Now it can be done virtually, which makes it faster, more efficient, and can give more touch points. So lots and lots of ways the practice of medicine will change, including virtual care, including using diagnostic tools in your home, including using chatbots. Talk to your Amazon Alexa or Google Home when you need some advice. Part of the challenge now is the human doctors and nurses and pharmacists who spend so much time, running between rooms with less time to see patients and typing medical records into the computer, or losing some of the human touch, that face-to-face time. Hopefully, my hope, and for many others, is we can rehumanize healthcare and let the technology get out of the way, augment us. So when you come to see me and you have a stomach problem, I'm not asking you questions for the first time. How were you last week? What worked? What didn't work? We'll have all the data from your phone and your virtual nutritionist. Tell me how you're doing. Maybe looking at your sleep data, your heart data, and I will help synthesize that and integrate and make decisions with you as your doctor. So I think we can bring back more of the human touch, but bring into that the knowledge that, let's say, machine learning and AI does. So we make less mistakes. We pick the right drug or dose based on you. I'm doing a new company. You can watch my last TED Talk on 3D printing medications, where you may have an AI engine sort of tell you what kind of medications to print in one pill for your patient. Instead of taking 5 pills, you'll take 1 pill with the drugs and doses that match you.
Is this already a reality? I can do that for me?
Not yet. We're building that technology today, so that the future of taking medications is a pill built for Patricia, not for John, and then it can change and adapt based on your data. I haven't seen the longevity talk, but we know that more important than your genetics is your zip code, where you live, how your human connections are, your happiness levels, often based upon your friends, your neighbors, your family, sense of purpose, a balanced life. There's been studies of parts of the world where people live a long, healthy, and happy life. Often they're called the blue zones. Dan Buettner has a whole book called The Blue Zones. And now they're starting to study what gives someone happiness. It's not just having money. It's not just driving a fancy car. It's often a combination of factors. And those together, and we'll hear from Dean Ornish and Ann Ornish about some of the things about diet, yoga, meditation, all those things that can really contribute to a happier, healthier, longer, healthy life. Hope you and some of your folks watching can come to Exponential Medicine. It's November 4th through 7th in San Diego. ExponentialMedicine.com has a lot of great talks that people might want to watch that dives into everything from gene therapy to chatbots to digital health to 3D printing.